here we are again. We're back to our original camera position. So we are talking about arguments for the universe having a beginning or the past being finite, which roughly means the same thing. And so I mentioned that there were going to be a few scientific arguments and a few philosophical arguments. And in the last video, I talked about the evidence from the second law of thermodynamics. Today, I'm going to talk about the evidence from Big Bang cosmology. I'm not going to explain what the evidence is for the Big Bang because I think almost everybody accepts that the Big Bang happened, but I will leave a couple of videos, links to videos in the description down below. One of them is from PBS Spacetime, and one of them is from FermiLab. There's this guy named Don Lincoln who works at FermiLab. I think it's in Illinois. Anyway, he's got a YouTube channel, and he's got some awesome stuff on there. So anywho, so according to Don Lincoln and Matt Dowell or Dowdy or something, I don't know what his last name is. According to both of them, we know an awful lot about the universe back to a certain point. I think it's like 10 to the negative 32 seconds after the beginning of it all, or the supposed beginning. And according to Matt, the universe was like the size of a grain of sand at that point. So that's pretty extraordinary if you think about it. But we can't know what happened before that because a lot of what we know is because of what they figured out through particle accelerators, creating these really high energy situations and finding out that certain predictions that our math has come to fruition or whatever. And so from that they can figure stuff out, but they can't figure stuff out earlier than that. So anyway, the Big Bang theory does not absolutely prove that the universe had a beginning, but I think it points in that direction for a couple of reasons. One reason is because, the universe is expanding, and if you just extrapolate back in time, eventually you're just going to hit a wall. There's just you can't go back farther than that. So it seems to be a beginning. That's one reason. Another reason is because given all these other arguments we have for the beginning of the universe, including the argument from the second law of thermodynamics, something like a Big Bang is what we would expect if the universe did have a beginning. And so that's kind of an abductive argument for the universe having a beginning. So that's two reasons. But they're not certain for a couple of reasons. One reason is because, well, I'll get into that in a second. It's because there's three different possibilities for what happened at the very beginning. One is that before the Big Bang, there was a big crunch. Everything came together. Another is that there was some like really tiny speck that just existed forever before it started expanding. And the third is that the universe actually began at the Big Bang. That's the very beginning of it. So those are the three possibilities, and logically it seems like those are those are exhaustive. I mean, I don't see how there could be a fourth possibility. Either it was preceded by a big crunch, or it existed in this tiny little thing forever before expanding, or that was the very beginning of it. Time began. So let's look at the other two possibilities besides time beginning. The big crunch. There are two problems with the big crunch. One of the problems is that they figured out, I think back in 1999 or 2000, right around there, they were trying to, it used to be that we assumed that because of gravity that the expansion of the universe must be slowing down. And the big question back then was whether it was slowing down fast enough to cause a big crunch, or if it was just going to keep expanding forever. There was a balancing act between, the momentum outward and the gravitational force of attraction inward. So they wanted to figure this out, but what they figured out was something surprising, that the expansion is actually accelerating instead of slowing down, which is what everybody predicted. It's actually accelerating. And so so that's where they come up with dark energy, because dark energy is like the placeholder for the I know not what is causing the outward push. And there's a lot of theories about that. I even have one myself, but I'm not going to tell you what it is because it doesn't matter. So given the way, you know, space and everything works, there couldn't have been a big crunch if there's this natural force outward. And so we're definitely in an open universe. There's never going to be a big crunch. So the whole idea that the universe is like an oscillating expansion, contraction kind of thing, that's out the window. So that's one reason the big crunch is not feasible. Another is because it violates relativity, general relativity. If you apply the math of general relativity to, you know, every geodesic, you know, every little path back to the beginning, to get from a big crunch to an expansion, you would have to have everything come together, maybe really close, but basically kind of miss each other and then go off expanding again. But according to general relativity, and I think Hawking and Penrose proved this in some paper they wrote a long time ago, that every geodesic, there's no way to avoid the singularity. And a singularity is a situation where everything converges to a point that has no volume, zero volume, and infinite density. And so because it has zero volume and infinite density, you cannot extrapolate past that. It's like going north of the North Pole kind of thing. You know, you can't go through a singularity. And so there's no way for there to have been a big crunch if that's true. I mean, the singularity had to have been the beginning of it all. Now, there is one snag about that, and it's the major snag, is that a singularity is physically impossible. Usually when a singularity shows up in our physics, it means that the law breaks down at that point. And so in this case, relativity breaks down. And so as Don Lemon was explaining, Don Lemon? Not Don Lemon. I don't remember the guy from the FermiLab. Don Lincoln, I think is his name. Don Lincoln was explaining is you cannot extrapolate prior to the Planck length, shorter than the Planck length. And the Planck length, I think, is like 10 to the negative 43 meters or something, like teeny tiny little thing. And the problem is that that it's at that point that it's believed by the knowers who know that general relativity breaks down at that point, because quantum gravitational effects start becoming predominant. They start kind of taking over. And until we have a theory of quantum gravity, there's no way to explain what's going on. And so this leaves a little wiggle room for the beginning of the universe, since we don't know what was going on during that Planck time and that Planck length or whatever. There's Planck time and Planck. There's Planck all kinds of stuff. There's Planck energy, Planck mass. There's Planck. With the whole idea of these Planck dimensions is it's a derived dimension that's derived using unit analysis to come up with a unitless measure thing. And the whole idea behind it is if we ever ran into aliens, that we could communicate with them. So anyway, so you got this Planck length, and we can't know what happened before that, because all of our laws of physics, all the known laws of physics, break down at that point, or they're superseded by a quantum theory of gravity, which we don't have. We don't have a quantum theory of gravity to explain what's going on there. So because there's this big unknown, we don't really know, we can't really say for certain that the Big Bang is the beginning of the universe, because, there's this unknown or whatever. So there's a lot of people that think that this is kind of a sidebar. not totally related to the video, just something I think is interesting. There's a lot of people that think that the Planck length is actually the smallest unit of space, that space is actually quantized in Planck length increments, and same thing with time. But I was really curious about this 2 or 3 years ago, and so I wanted to, get to the bottom of it and find out, read as much stuff and talk to some physicists. I watched a bunch of YouTube videos, I read some papers, and I even talked to some physicists about this. And the bottom line is that nobody knows whether space and time are quantized. I personally do not think they are. There are a couple of experiments I've found that seem to indicate that they're not quantized. And besides that, there are different things about space and gravity that differ from quantum particle physics. And so I don't think that you can quantize space and time for the same reasons that you can quantize things like light or electricity, or the particles and stuff like that, quantum fields. So anyway, that's beside anything that I'm talking about. So anyway, that's okay. So, I mentioned earlier in the video that there are 3 possibilities: that the Big Bang is the beginning of the universe, that it was preceded by a big crunch, and the third one is that you had a particle sitting there forever. And so let me talk about that one, that you had a particle sitting there forever before it expanded. This one I think is the least likely of the 3, because if you had a particle sitting there forever, then it had the potential that whole time to begin expanding. And so whatever the necessary and sufficient conditions that there had to be for something to have existed forever before expanding was always there. And so there's no point in the finite past in which it shouldn't have already expanded. And so it doesn't seem physically possible for something to have existed forever before expanding. So that one's a total no-go for me. There's one other reason to doubt the whole idea that the universe just kind of sat there as a little speak for an infinite amount of time. And that's because of the arguments I'm going to bring up later in this series about the impossibility of the past being infinite due to logical or mathematical reasons or whatever. So there's 2 arguments against that. So it's between either the universe beginning to exist and the universe being preceded by a big crunch. The big crunch is at least possible, although it seems highly unlikely, because just looking at what we know, everything kind of converges to a point, and you can't extrapolate past that. And it doesn't look like there would have been a big crunch because of the accelerated expansion of the universe. And so it looks like the Big Bang was actually the beginning of the universe. Although not certain, that's kind of the direction things seem to be. That combined with the fact that all the other arguments for beginning of the universe seem to predict something like a Big Bang. So anyway, there you have it. So next time I'm going to talk about a different argument for the beginning of the universe.